And now let's check out the second question. We have to collect the definitions of property of these stochastic processes. The first is White-Sands stationary process. The White-Sands process, if x of t has a mean of eta, which is a constant, and autocorrelation of t1 and t2 is a function of tau, where tau equals t1 minus t2, then we can say that x of t is White-Sands stationary process. And second, independent increment process. The definition is if x of t2 minus x of t1 and x of t4 minus x of t3 are independent for any t1 less than t2 less than t3 less than t4, then we can say that x of t is a process with independent increments. The third is Markov process. Suppose in a timeline in this figure there are several time points, and we suppose that t1 is greater than t2 and greater than tn. If the probability of x of t1 greater than or equal to x1 given x of t2 is less than or equal to x2 and x tn is is less than or equal to xn, the probability equals the probability of x of t1 greater than or equal to x1 given x of t2 less than or equal to x2. Then x of t is a Markov process. For Markov process, we just know that its second-order distribution function is enough to characterize the whole stochastics, the whole statistics. And the fourth is straight-sense stationary process. If a stochastic process is called SSS, if its statistical properties are time invariant to a shift of a region, that is, for any c, x of t and x of t plus c have the same statistic properties, and it follows that an nth order density of an straight-sense stationary process must be like this for any c. And let's focus on its first order density. We can say that f of x t is independent of t, since f of xt must equal to f of x t plus c for any c. So the first order density function is just f of x. Similarly, the second order density function is a function of tau, where tau equals t1 minus t2. The next one is white noise process. If n of t1 and n of t2 are uncorrelated for any t1 isn't equal to t2, then we can say that n of t is white noise. Additionally, if n of t1 and n of t2 are not only uncorrelated but also independent, we can say that this white noise process is strictly white noise. Last, I'd like to say some comment about this 5 stochastic process. The first comment is stationary process is time invariant. So suppose we are observing a spinning machine and recording the diameter of its product. When we compare the statistics which we choose at several moments, we can find that the diameter is independent with time, or it is independent with direct time, but with related time. So we can say it's time invariant. And no matter how we shift the interval of time, it's the same. and it's a stationary process in our everyday life. And the second common is when we say independent increment, we know that Poisson processes, Brownian movement are all examples of it. For any two non-overlapping intervals, the two increments are independent, and we can say independent increments is a special case of Markov process. And when we talk about Markov process in the real world, there are many Markov processes, such as the number of infected people for contagion, or the number of waiting people in a bus station, and so on. And last is about white noise. White noise actually is not just a noise which we encounter in our daily life. In the Poland, it's a good frequency. It can help us a lot. It can even help us get into being relaxed and get into deep sleep more easily. And so it's also widely used in our daily life. Thank you.